Hello friends, welcome back to another video on this channel. In today's video I will show you how you can make a smart dustbin that opens without any contact. So as you can see, I have my hand here, and as you can see, when I put it here, the hand opens the lid. So it has an ultrasonic distance sensor which can detect when a hand is in front of it. So as you can see, when I put my hand in front, it will open it. It opens the lid, and then I can put a trash in there. When I move my hand away, it closes the lid. So basically there is two servos here. So when I move this, the servos move down, which pushes down on this pedal, opening the lid, as you can see. And then when I move my hand away, it can detect that there is no object nearby, and it closes the lid. The way it works is simple. So there, on this I have set a 20 centimeter distance. So when something is within 20 centimeters of it, like this, so if it is powered on, as you can see, it will open it, and then when I move it away, it closes the hand. So this is because, as you can see, when I can move away till this far, and then it will close. So that's above more than 20 centimeters, so it's closing, and when I take it nearer, it opens the lid. Now if I turn this off, take it apart, take this off, and then if I put it up to the bottom, you can see the actual electronics hidden in here. So basically I have very simple electronics, very simple schematics as well. So I have a Arduino Nano microcontroller. This is plugged in through the VIN and ground into a breadboard power rail, which is connected to a USB plug, which is going into the power bank here. As you can see, this is the USB plug going in here. Aside from the microcontroller, we also have, on the microcontroller, we have four more connections: two servos and two for the VIN and the sorry, not VIN, the echo and the trigger pin on the this ultrasonic sensor here. Now, for speaking of the ultrasonic sensor, its two wires, the voltage and ground, also plug into the same rail. So does the voltage and rail ground for these two servo pins. So as you can see, this one is stuck on this side. It's going in here under this, and it's coming in, plugging in there. And this one is coming from here. The power rail split off and plug in there, whereas the signal rail goes out and plugs in here. Same with this one. As you can see, there is one coming from here, the blue one, which is plugging into the signal rail here. It comes out here and plugs in into the microcontroller. So on the microcontroller there is only 4 and 2 6 connections. It's really a simple build as well, much like my previous build, which you should check out, link in the description. So you can see this is a simple little wiring. I will not leave a schematics down for this, as it is really simple. The echo and trigger yes, the echo and trigger pins as well as the servos are actually marked in the sketch. I'll show that in just a little bit. The code, as you can see, it's running in the background. You can change them as well if you like, and of course this is possible with some other microcontroller like the Arduino Uno as well. Here I'm using the Nano just because it's super small and convenient to just shove in here. I don't even have it like plug. This one is double-sided taped onto there, but this one is just literally hanging out here. As you can see, it's not the best way to go do this, but you know, it just works. So let's just not look at this anymore. Let's just take it apart. Of course, there's a much better way this can be done, but hey, if it works, it works, right? Okay, so as you can see, I have switched over to the computer now. Over here we have the code running on the microcontroller. This is a simple code, but this is quite small as well. It's just a couple of lines, only like 5 lines. So let's start by the explanation. So here we are just including the one library, which is the servo library, which is there by default on the Arduino IDE. Next, down here we are defining the trigger and the echo pins, as I said. So these are where your the ultrasonic sensor plugs in. Echo pin goes to 7 and trigger pin goes to 8. Next we are creating the servo objects, my servo and my servo 1. Here we are just attaching the servos on pin number 9 and 10, as I said. So it's 7, 8, 9 and 10. Then we are setting the trigger pin to output and echo pin to input. Next we are just creating a loop for here, this part till here. So all of this is just for simply the basically this is for like the the distance sensing for the ultrasonic distance sensor. So this is where it calculates the distance using all of these calculations here. It's not that complicated. It's just a simple little process where it sends out a ultrasonic wave, and when the receiver when the echo pin receives it, it can calculate the time taken and it knows the speed of sound, so it can calculate how far the distance is pretty accurately. So here we are just saying if it is out of range, that is if it is greater than 200 or less than 0, because these HC05s are rated only for like 100 something centimeters. So to be on the high, say like 200 something centimeters, to be on the same side, for accuracy we are doing 200, and of course the distance cannot be negative, so less than 0, that's an error, so it's set out of range. Then here we are just saying to keep the lid shut if it goes out of range. Then here we have otherwise it will print out the distance centimeter on the serial monitor. Then next what it does is it will check whether the distance is less than or equal to 20 centimeters. So I decided to go with 20 because it's like when this is in the ground, it's about the right height where you accidentally trigger it, but like if when you want to trigger it, it's not that you have to go at very close to it. So you can change this based on your preferring and all. So this is the one variable you would like to change. Next, if you then we are writing it down for up. So this is the lid, which when the lid is up, if it is less than 20 centimeters, and if it is greater than 20 centimeters, here we are defining to put the lid down. So it writes that down on the serial, and then we have a 500 milliseconds delay, so that it doesn't like load up the microcontroller too much, because this is not really a super critical, it's half a second, we can wait that much time for it to refresh it and check whether it's close or far away. So that's basically it for the code as well. I'm using the Arduino Nano, so it's not currently connected to the computer, but yeah, when you have the Arduino Nano, you can upload it from here. You can select the board and the port. Here you have every single board on here, so we have the Nano as well. There it is. If you are using something like the Mega, which I don't know why you would use a Mega for this purpose, but if you are, you can use that too, or of course the good old Uno, the normal Arduino Uno, which is the most common Arduino in fact. So yeah, that's basically it for this. I hope you guys enjoyed this video. If you did, please be sure to leave a like and subscribe to the channel if you are new. Also, you should check out some of my other projects using Arduinos and other similar microcontrollers. So I'll leave the playlist in the end card as well as in the iCard up there. So please check those out too, and share this with your friends. And yeah, I'll see you guys next time. Bye.